Hey guys, today's lesson is going to be an introduction to inequalities. Now, I'm sure that when I say inequality, a whole bunch of different things come to mind, like financial inequality, or racial inequality, or gender inequality. But we're going to talk about mathematical inequalities today. So although we're not going to be solving the world's problems, we're going to be solving math problems, which don't have just one correct solution. There is a range of possible correct solutions, much like the problems we have in the world today. Let's get started. Now, an inequality simply means that it's not equal. So if I say A equals 7, A has a specific value. A is equal to 7. Now I can show you that on a number line here. The only value that A has is the 7. But when we talk about inequalities, like this one here, I hope you recognize this symbol here as being A is on the smaller side of the symbol, so A is less than 7, which is on the bigger side of the symbol. If I show you that on a number line, what that means is that A is not 7, but 7 is a very important number. It's a critical value or a boundary value for A because A is not 7. A is less than 7. So any value below 7, including 6.999999999, and you could keep going, A is any value up to 7, but not including 7. Now this inequality here shows that A is clearly on the bigger side of the inequality side. So that means that reading this in a sentence, A is bigger than or greater than 7, which is on the smaller side. So again, on a number line, 7 is a very important number for me to see on my number line, but A is not equal to 7. A is greater than 7. Now this symbol looks very similar to the symbol we saw above. A is on the smaller side of the symbol, but this symbol is underlined. If I cover the top part of that symbol, it almost looks like it's an equal sign. A, you could say, is equal to or less than 7. So putting an equal sign and a less than sign together there, A could have the value of 7, or it could have any value less than that. So we're coloring in the number 7 on the number line, and we're showing an arrow going downward, showing all of the values less than 7, including 7 this time. And this one, I'm sure you could guess, means that A, which is on the bigger side of the symbol, A is greater than, or, because this is underlined, equal to 7. So once again on the number line, I can show 7 is a very important number. It's my critical value, and I draw an arrow going up from there that A could be equal to 7 or greater than 7. Now, putting inequalities into words, you're going to want to write this down. This is the greater than symbol, because if we read it in a sentence, we would say something is on the bigger side than the other side. So something is greater than the next value. Right? So here we would say A is greater than B. This is my less than symbol because, again, if I read this in a sentence, I would start on the left-hand side and I would say that's the smaller side. This is less than whatever comes after it. So again, as an example, I would say that C is less than D. Now, again, this is my greater than symbol, but it's underlined. That means that the value that comes before it is greater than or equal to the value that comes after. So our example, E is greater than or equal to F. And finally, our last symbol that we learned is the less than or equal to symbol, where we would see the number that comes before this symbol is on the smaller side. It is less than the value that comes after the symbol. So that means G is less than or equal to H. Going on to combined inequalities, this is where we've got more than one critical value. That is more than one boundary value. And as you see, I've combined them together to show what values B falls between. When we write combined inequalities, the best, easiest, and most reliable way is to set your values out first from smallest to biggest. So as you see, I've listed my numbers here, -3 to +3, and the order from smallest to biggest. That way, generally, I know how to put the symbols. They are going from smallest to biggest. Here I'm going from smallest to biggest, but this one's underlined. Remember that means less than or equal to. By setting out my combined inequalities in this way, I can show this inequality on a number line, and I can see that my boundary values are the same order as they are on the number line. -3 comes before +3. Now check your inequality symbols carefully. This is the way we want to see them if our numbers are in order from smallest to biggest. But there are exceptions where they try to fool you, where they've got the inequality signs the other way around. We'll come to that. So putting this inequality, this combined inequality on this number line, I want to show my critical values -3 and +3 clearly by either putting a circle. This one's not colored in because this inequality is not underlined. B cannot be equal to -3. B must be greater than -3. And for my other boundary value, I'm putting a circle, but I am coloring it in because B is less than or equal to +3. So I color that in and I show which values B could have. We're not saying that B is equal to 3 and -3. We're saying that -3 is less than B. So B is on the upper side of this circle, and B is less than or equal to +3. So B is on the lower side of this circle. We show that with a line that combines these two inequalities to make a single combined inequality. B is somewhere on this number line bounded by these two critical values. So that means if B were an integer value, integer meaning whole number, that would mean that B could be any value within this set of numbers from -2, -1, 0, 1, 2, and we are including 3 because it's colored in, because it was underlined. B could have any of these values. Now, B may or may not be an integer value, but this is very often a question you'll get on a test or exam. They'll say list all possible integer values for our variable B. So there we have it. Here's another example of a combined inequality, but as you can see, there's something wrong with it. Maybe you don't notice it at first, but look at my number line. The number line doesn't have to start at 0, but it needs to have both of the critical values on it. And I do see 2 there, and I do see -4 there, but they're not in the same order as I have them written in my inequality. My inequality is not written from smallest to biggest. -4 is much smaller than +2. Nor have I got my inequality sign going from smallest to biggest. I've got them going from biggest to smallest in both cases. So let me turn that around for you so that it'll be easier to put on your number line. The smallest value is the -4, the biggest value is the 2, the C should go in between, and let's see those inequality signs. The C is on the bigger side of this inequality between -4 and C. C is on the bigger side. And C is on the smaller side of this inequality between 2 and C. So C is on the smaller side. Now that I have it set up from smallest to biggest, and I've got my C in the middle, and I've got my inequality signs going from small to big, again, small to big, I can put that on my number line. So I'll mark my critical values. One of them is -4, and I've colored that in because in both cases, that inequality was number line, so C could be equal to -4. My other critical value, my other boundary point, is 2. And again, I colored that in because this is underlined. C could possibly be equal to 2 in both cases. Now C is greater than -4 or equal to -4, so I'll have a line coming upwards from -4. And C is less than or equal to 2, so I'll have a line coming down from 2. And they join together, they combine to make this combined inequality number line. Once again, if C were an integer value, it could have any of the values within this set of values. It could be -4 because that's colored in. -3, -2, -1, 0, 1, and it could be 2 because again that's colored in. If C were an integer value, it could have any of these 1, 2, 3, 4, 5, 6, 7 possible values. However, if C were not an integer value, that would mean it could have any value, even a decimal value. It would have infinite possible values. Here's another combined inequality, and this is where it gets really interesting. Notice again that my inequality is not quite in the right format. I do have my numbers going from smallest to biggest. -7 is smaller than -2. However, look at my symbols. It looks like -7 is on the bigger side of this inequality, so C is less than -7. And C is on the bigger side of this inequality, so C is greater than -2. Now, why is that a problem? Well, if the numbers go from smallest to biggest, but the symbols seem to go from biggest to smallest, that's not a combined inequality. We have to split that up into two separate inequalities because C is smaller than the smaller value and bigger than the bigger value. Let's do this step by step so you can understand. First of all, our boundary values are -7 and -2, so let's put them on there. -7 is an upper boundary for C. As you can see, C is smaller than or equal to -7. Even up here, we should be able to see that. C is on the smaller side of this symbol. C is smaller than or equal to -7. So from here, I need a line going downwards. And C compared to the -2, well, C is on the bigger side of that inequality. C is greater than -2. Up here, we should see that as well. C is on the bigger side of this inequality. C is upwards from -2. So although we've been given a combined inequality, it was not in the correct format, and it shouldn't have been written as a combined inequality. It should be written as two separate inequalities. So C could either be -7 or below, or it could be greater than -2. Obviously, it can't be both at the same time, so we can't combine. Now, here are some reminders for you to write down before we get into the practice. Remember that inequalities do not give you one single answer. They get a set of possible answers. When you have an underlined inequality sign, it means that you need to include the boundary value in your set of possible answers. And when you have an underlined inequality, and we put that on a number line, remember to color in those boundary values to include them in your set of possible answers. To combine inequalities, remember it's best to list the boundary values in order from smallest to largest, and we put the variable in between. Then take special care when you're placing the inequality signs to show correct direction. They should go from smallest to largest, but they don't always. And if they don't, remember it's not a combined inequality. We need to split that off and make two separate inequalities. Now let's get into some practice. All I want you to do here is set up number lines to express these inequalities. And in the case of questions E, F, G, and H are combined inequalities, check to make sure that you've got the numbers in order from smallest to biggest, and the symbols are going from smallest to biggest, because if they're not, it is not a combined inequality. Part I, given that E, F, and H are all integer values, list all possible values for these variables. Go ahead and hit pause now and give that a try, and your answers will come up in just a moment. I hope you had time to hit pause and you've drawn nice, neat number lines. Here come your answers. For A, I've shown that A is greater than, but not equal to -3, so it's not colored in. B is less than or equal to 5, so I've colored it in and drawn an arrow down. C is greater than or equal to 2, so it's colored in on 2 and up. D is less than or equal to -8, so I've colored in -8 and drawn a line going down from there. E is in between 2 and 6, but we see the inequality between E and 6 is underlined, so it's colored in. F is between -3 and +1, where F could possibly be -3, so we've colored that in. G looks a bit wrong. We've got our boundary values at 4 and 7, coloring in the boundary at 7 because that inequality was not underlined. However, G is less than 4 or greater than or equal to 7. So that is not a combined inequality. And H is between -2 and -1. Both of the inequalities were not underlined, so both of the boundary values are colored in. Given that E, F, and H are all integer values, well, E cannot be 2. It can be any value greater than 2 up to and including 6. So E could be 3, 4, 5, or 6. F could be -3 and any value up to but not including 1. So -3, -2, -1, 0, not 1. H is in between -2 and -1, including both boundary values, so H could be -2 or -1. Notice I didn't ask you about G, because the values that G could have are infinite. Any value less than 4, or any value greater than or equal to 7. There are infinite possible values for G. Now let's turn this practice around. This time I'm giving you the number lines, and I want you to write the inequalities that go along with them. Go ahead and use the letters A, B, C, and D as they are labeled for the questions, and write the inequality such as A is greater than or less than 5. Okay, go ahead and hit pause, copy the number lines, and write the inequalities that go along with them just below. I hope you had a chance to hit pause because here come the answers. For the first line, I've written all of my inequalities in the format that shows the number or variable that is less than or equal to the other number or variable. But you could have written this in the other order as well. So where I say 5 is less than A, I could have also said A is greater than 5. Question E, F, G, and H. Most of these are combined inequalities, so you should have written them in order from smallest to biggest with your variable in between. Last row. Again, these are combined inequalities for the most case, except for J and L. In the case of J, J is less than 16, or you could have said that 16 was greater than J. In the case of L, we should not combine these for our inequality because the number line does not join. L is definitely less than or equal to 7, or L is greater than or equal to 10. I hope that you found this introduction to inequalities helpful, and look out for our next lesson on solving inequalities. I'll see you then. Keep practicing.